Okay, problem 3 is next, the steamboat problem. Mark Twain sat on the deck of a river steamboat. As the paddle wheel turned, a point on the paddle blade moved so that its distance d from the water surface was a sinusoidal function of time. When Twain's stopwatch read 4 seconds, the point was at its highest, 16 feet above the water surface. The wheel's diameter was 18 feet, and it completed a revolution every 10 seconds. So let's sketch this one. This is problem number 3. And we're told that the high point was 16 feet above the water surface. Since the diameter is 18, we're going to be below the water for part of this, so I'm going to move my x-axis up a little bit. So this is x, and this is the y-axis. That's y. Now we're told that the high point is 16 feet. So let's call this 16. That's my high point. So I'm going to draw me a broken line here. Now to get to the low point, I have to take 16 minus the diameter of the wheel. Well, the diameter of the wheel was 18, so my low point is going to be at -2. This is -2. That's our low point. Now let's find amplitude. Amplitude is going to be the high, 16, minus the low, so that's +2 over 2, so that's going to be 9. A is 9. The vertical shift is the high plus the low. That's 16 minus 2 divided by 2, so that's going to be 7. That's going to be our D, 7. So +7 will be about right here, let's see. Call that 7. This is going to be our D value. Now this is the shift in the x-axis, so we're going to call this x prime. That's our x prime. Now we are told that the period is 10 seconds. So we can get B, 2 pi over 10 is just pi over 5. That's that. Okay, with this, now let's work out where we are here. At 4 seconds, he's at his highest, so this is the x-axis. So let's call this 4. And we know at 4 seconds he's going to be up here. That's the highest point. Every 10 seconds, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is 14. He's going to be back up here because the period is 10 seconds, and 10 plus 4 is 14. Halfway between these two, which will be at 9, he's going to be at the bottom. So 5, 6, 7, 8, 9. Here he's at the bottom. Okay. Now, since we're going to start at 4, we're going to move laterally or horizontally 4 units. This becomes our y prime. So this is y prime. So the shift from 0 to here is going to be 4. That's the phase shift. So we shift over 4 units. Now let's sketch our graph. That's our graph. Now, one key point on the graph is going to be at 4 seconds and 16 feet. Another key point will be at 5, 6, 7, 8, 9. Now this should have come a little lower. It should have been down here. 9 and -2. So let me try to correct that graph a little bit. So this should have come down to here like that, and then back up. So the graph should look like this. Okay, now we got pretty much everything we need, but if we look at this, this is the new origin here, and you can see we're starting up here. Can't be a sine because it doesn't start at the new origin. It starts up here, it's cosine, and this is a positive direction, so we're going to use this equation here. You have to put that y equals in there. Y equals a, which is 9 cosine of b pi over 5 times x minus c, 4, plus d, plus 7. Now we're asking the question to go out to 17 seconds here. So 15, 16, 14, 15, 16, 17. So let's go out to 18. Let's set up our window. So for the x-axis we need to go to 18, so we'll go with a minimum of 0 and go out to 20. And for the y-axis we have to be below -2, so let's try -3, and we'll go up to 18. See? Now go to y equals, clear out whatever you've got in there. Let's put in 9 cosine pi divided by 5 x minus 4 plus 7, and graph it. Now let's see where we are. The window, we started at 0. Let's change that to 4 and get a more accurate window. Yeah. Now that looks like our graph there. Let's check our key points. So if we go second, trace 1, and put in 4, we hope to get 16, and we did. We put in 9, we hope to get -2, and we did. And the question was, at 17 seconds, how far above the surface are we? So we're going to put in 17, and the answer is 4.22 feet. Okay, so that's problem 3.